Hi children, how are you? I hope all are fine. Yes, very good. So today I am going to teach about in the extractive metallurgy of copper in the periodic classification of elements. Okay. So last class, what we saw in the last class topics is metallurgy and metallurgy separation and then the extractive metallurgy of aluminium. Yes, so now we are going to see about the extractive metallurgy of copper. Okay, extractive metallurgy of copper. So this is the copper metal. The copper metal color is reddish brown. Reddish brown metal. So copper, the symbol is Cu. The atomic number is 29. The atomic mass is 63.55. Okay, so copper, what is the symbol? Cu. Copper symbol is Cu. Then atomic number is 29 and then color is reddish brown. Then the atomic mass is 63.55. Okay, so in the occurrence, so who called the cuprum in copper? So it was the named as cuprum by the Romans. Okay, so by the Romans is called cuprum. Okay, Romans is called cuprum. Then where cuprum was taken from? Yes, so it was named as cuprum by the Romans because they got it from the island of Cyprus. Okay, island of Cyprus. Then the copper is found in native state and combined state. Native state and then combined state. Then the ores of copper. Then the ores of copper. The ores of copper is copper pyrites. Copper pyrites formula CuFeS2. Then cuprite or ruby copper Cu2O. Then copper glands Cu2S. Okay, so in formula of ores of copper, copper pyrites CuFeS2, cuprite or ruby copper Cu2O, then copper glands Cu2S. Okay, then the important role of copper is copper pyrites. Copper is copper pyrites. Then the yield is 76% of the world production of copper. Then the extraction of copper is concentration of ore and roasting and smelting and besimerization and refining method. Okay, so 5 method, the concentration of the extraction of copper method. So first one in the concentration of ore. So the ore is fine powder, crushed in fine powder. The ore is crushed and then concentration of fourth flotation process method. Okay, fourth flotation process method. Fourth flotation process. Yes. One container. That container is mixed with oil, water, and then ore particles. So it will pass the current in compressed with air. So the form is formed. The fourth form is formed. So the form is collected and again the washed in water. So the ore is collected. So this is the fourth flotation process. So the concentration of ore in copper, the ore is crushed and the concentrated by fourth flotation process. Next one, roasting process. So in the roasting process, the concentration of ore is roasted in the excess of air. Okay, so the concentration of ore is roasted in excess of air. During the process roasting, the moistures and volatile impurities are removed. Okay, the ore is roasted, the ore present in the water is removed. Okay, during the process roasting, the moisture and volatile impurities are removed. Example, sulfur, phosphorus, arsenic and antimony are removed as oxides. Okay, sulfur S, phosphorus P, arsenic Ar. Okay, so these metals are removed as oxide. So copper pyrites is partially converted into sulfides of copper and iron. So on reactions, so 2CuFeS2. So CuFeS2 is copper pyrites. Copper pyrites is react with oxygen. So give the product is Cu2S. Cu2S means yes, copper glands. Very good. Copper glands. And 2FeS. And sulfur dioxide is evolved. Okay, so the reaction is copper pyrites. Copper pyrites formula CuFeS2. Then they react with oxygen. Then give the product is copper glands and iron sulfide, then sulfur dioxide, then smelting process. So the roasted ore is mixed with powdered the coke and sand. So the coke means C, then and sand, and is heated in the blast furnace to obtain the mate. So the mate, the mixture is copper glands and iron sulfide. Okay, the mixture is copper glands and iron sulfide. So the copper glands Cu2S, iron sulfide Fe(S). So and it slag. So the slag is removed as waste. The slag is removed as waste. So what is the difference between roasting and smelting? So the smelting is process of extracting metal by heating metal oxide with a suitable reducing agent as carbon and hydrogen. Okay, smelting is the process of extracting metal by heating metal oxide with a suitable reducing agent as carbon and hydrogen. Then the roasting involves heat. Okay, the roasting involves heating of ore either alone or in presence of oxidizing agent, mostly oxygen. Okay, this is the difference between roasting and smelting. Okay, next one is the bessemerization. So in the bessemerization is how is copper obtained by bessemerization? So the air is blown through to the molten meat. Okay, through to the molten meat. So in the blast of air converts the copper glands. Okay, copper glands it's partially into ruby copper or cuprite. Okay, so the copper glands is converted the partially into copper, ruby copper or cuprite. Okay, so in this reaction with remaining copper glands to give molten copper. So the copper so obtained is called blister copper. So the blister copper means the 99% of pure copper is the name is blister copper. So the copper so obtained is called blister copper because as it solidifies then sulfur dioxide is hidden in it escapes out producing blister. On its the surface blister copper is 99% of pure copper. Okay, so in the reaction so the iron sulfide is react with oxygen to form iron oxide. Okay, so the metal is react with oxygen is metal oxide. Metal is iron, oxygen oxide. Okay, so the iron sulfide is react with oxygen to give iron oxide. Then sulfur dioxide is evolved. Then the mixture of metal oxide is the slag. Okay, so iron oxide is react with the silicon oxide. Okay, iron oxide FeO, silicon dioxide SiO2. So iron oxide is react with the silicon dioxide to give the product is iron silicon trioxide. Okay, iron silicate. Okay, iron silicon trioxide is the name is iron silicate. The formula is FeSiO3. So O3 means FeO1 oxygen, then SiO2 3 oxygen. Okay, so the balancing the equation FeSiO3. Okay, so the first reaction is iron sulfide is react with oxygen to give the product is iron oxide. Then sulfur dioxide is evolved. Then iron oxide is react with silicon dioxide. So the given product is iron silicate is the slag. So in the iron silicate formula FeSiO3. Then the next equation copper glance. Okay, copper glance is Cu2S. So copper glance is react with the oxygen to give the copper ruby copper or cuprite. Okay, copper glance is react with the oxygen to give ruby copper or cuprite, and sulfur dioxide is evolved. So copper glance formula Cu2S, then oxygen O2, then the given product is ruby copper Cu2O. Then Cu2 ruby copper is react with repeated in the copper glance react with copper glance. Okay, so the ruby copper react with the copper glance. So first reaction, copper glance react with the oxygen to give the product is ruby copper. Then next reaction, ruby copper is react with copper glance to give the product is blister copper. So Cu is separated the extraction of metal is Cu. Okay, so blister copper. Then so this is the besmerization process. Then the refining process. Okay, refining process. So in the refining process, transfer of copper in pure form from the anode to cathode. Okay, transfer of copper in pure form from the anode to cathode. So pure copper deposited on the cathode, the process is electrolytic refining process. It is used to purify impure metals. So the blister copper contains 98% of pure copper, then remaining 2% of impurities. So in the impurities is purified by the electrolytic refining process. So in this method, this is the electrolytic refining method. So in this two rod, cathode rod and an anode rod. So what is cathode? So the cathode is the place in a battery or other electrical device where the electrical current lives. Then what is anode? The place on a battery or other electrical device where the electric current enters. Okay, this is anode and cathode. So which electrolyte is used in refining of copper? So the electrolyte is CuSO4, copper sulfide. So the electrolyte is copper sulfide CuSO4. Okay, so the refining process is the transfer of copper. So the flow of electron is anode positive charge and then cathode is negatively charged. So the impure copper is collected on anode, then the pure copper is collected on cathode. Okay, pure copper is collected on cathodes because so copper Cu is the positively charged, so is attract to the negatively charged. So the copper is collected in cathode rod. So the transfer of copper in pure form from the anode to cathode. This process is electrolytic refining process. So in this process, the impure metal is made anode and a thin strip of pure metal is made cathode. Okay, this is the electrolytic refining process. Okay, children. Then the physical properties of copper. So copper is a reddish brown metal. Okay, what is the color? Reddish brown metal with a high luster and high density and high melting point. So the melting point is 1356 degree Celsius. So the physical property is copper is a reddish brown metal with a high luster and high density, high melting point. Okay, this is the physical property of the copper. The chemical properties of copper. So in the first point, action of air and moisture, then action of heat, then action of acid. So the acid is dilute HCl and dilute sulfuric acid, then dilute nitric acid. Okay, so the first point, the action of air and moisture. So the copper gets converted with a green layer of basic copper. Okay, basic copper. Then carbonate in the presence of carbon dioxide and moisture. So the metal is copper. So which is the metal? Copper. Copper is the metal. So copper is reactive with the presence of air. So in the presence of air, which elements are present? The metals, the elements like oxygen, nitrogen and carbon dioxide and sulfur dioxide. So these elements are present in the air. So the metal copper in the presence of air, oxygen and carbon dioxide and react with water. Okay, so water means the moisturites of the air. Okay, so then in the product is CuCO3 into CuOH2. Okay, this is the product copper carbonate. Okay, copper carbonate. So the action of air and moisture, the moisture means H2O, the air in the presence of oxygen, carbon dioxide and nitrogen. So in the copper is react with oxygen, carbon dioxide and H2O water is give the given product is copper carbonates. Okay, copper carbonates. So copper carbonates formula is CuCO3, then copper CuOH2. Then action of heat. The action of heat. So on heating at a different temperature in the presence of oxygen. Okay, different temperature, presence of oxygen, but temperature is different. So first one, the temperature is below 1370 Kelvin. The next reaction is above 1370 Kelvin. Okay, so the first reaction, copper is react with oxygen O2 is below 1370 Kelvin. The product is copper 2 oxide. Okay, the product is copper 2 oxide. The color is black color. Okay, the color is black color. Then below heating, so the copper is react with oxygen. The temperature is above 1370 Kelvin. The product is copper 1 oxide. Okay, copper 1 oxide. The color is red color. Okay, this is the action of heat reaction. Then the action of acid reaction. So with the dilute hydrochloric and dilute sulfuric acid, the dilute acids of hydrochloric and sulfuric. Hydrochloric HCl, sulfuric H2SO4. Okay, hydrochloric HCl, sulfuric H2SO4, sulfuric. Okay, so first reaction, copper is react with the hydrochloric acid in the presence of air to give the product is copper chloride, CuCl2. Okay, copper chloride, CuCl2. Cl2. Then the water is removed. This is the reaction with the dilute hydrochloric acid. Then the next reaction, they react with the dilute nitric acid. Okay, nitric acid HNO3. Okay, hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. So the copper reacts with dilute nitric acid with the liberated of nitrogen dioxide. Okay, liberated of nitrogen dioxide. So in the first reaction, hydrochloric acid removal of water molecule. In the second reaction, nitric acid is removal of nitric oxide. So the metal is copper is react with the nitric acid HNO3 is give the product is copper nitride CuNO3 2. Okay, copper nitride CuNO3. Then the nitric oxide is liberated. Then the water molecule is removed. Then the other reaction, copper metal is react with the sulfuric acid. Copper is react with sulfuric acid H2SO4 to give the product is copper sulfide CuSO4. Copper sulfide CuSO4. So in the liberated of sulfur dioxide gas, we liberated of copper sulfur dioxide gas and then removal of water molecule. Okay, in the reaction. So the next reaction, action of chlorine. So copper is react with chlorine to give the product as copper 2 chloride. Okay, copper 2 chloride. Then action of alkali metal. So copper is not attracted by alkali because copper is a transition metal. Okay, copper is a transition metal, is the B block element metal. So the transition metal, all elements have positive charge. Okay, positive charge. So in the positive charge is attract to the negatively charged only. So alkali metals are all positive charge. So the copper is not attached by alkalis. Okay, so the reactions, chemical properties of copper, the action of air and moisture. So copper react with the air, oxygen, carbon dioxide and water to give the product is copper carbonate. Okay, then action of heat is the different heat temperature, the presence of oxygen below 1370 and above 1370. The product is copper 2 oxide black color, then copper 1 oxide red color. Okay, then action of acid, copper is react with the hydrochloric acid is removal of water. The product is copper chloride. Then copper react with nitric acid is liberated with nitric oxide, then removal of water. Then the product is copper nitride. Then the copper is react with the sulfuric acid is give the product is copper sulfide CSO4. Then liberated of sulfur dioxide gas and removal of water. Then action of chlorine, copper is react with the chlorine, give the product is copper 2 chloride. Okay, then action of alkali metal. So the alkali metal, all metals are positive charge. So copper also positively charged, so it is not attracted. So copper is not attached to by alkali metal. Then the uses of copper. Then the uses of copper. The uses of copper is, it is used in manufacturing electric cables and other electric appliances. Okay, then the next point, it is used for making utensils, containers and calorimeter and coins. Then it is used in electroplating. materials. Then it is allied with gold and silver. It is allied with gold and silver. So gold is not pure metal. Some alloys is mixing in the gold. So 96.4 is the pure metal, then remaining other percentage is the alloy of zinc and copper. So it is allied with the gold and silver for making coin and jewels. Okay, this is the extractive of metallurgy of copper. The next topic, metallurgy of iron. So the extractive metallurgy of iron. This is iron. So the iron atomic number is 26, then the atomic mass is 55.845. Okay, the atomic number 26. Ion symbol is Fe. Okay, ion symbol is Fe, atomic number 26, atomic mass 55.845 is the atomic mass. So ion in the presence of d block element is the transition metal element. So in the ion is get the positive charge. So iron is the second most abundant metal, is available next to the aluminium. So the nature of oxide, sulfide and carbonates. Then the ores of iron. The ores of iron is hematite, magnetite and iron pyrites. Okay, so the first one, hematite. So the hematite formula is Fe2O3. Then magnetite is Fe3O4. Then iron pyrites FeS2. So hematite, magnetite and iron pyrites. So iron is chiefly extracted from the hematite ore Fe2O3. Then the extraction of iron. So in the concentration of gravity separation. So in the gravity separation or hydraulic wash method is the same process. So the powdered ore is washed with a stream of water. Okay, stream of water. So the ore can be made into the fine powder. It contains the slope surface powdered slope surface. The powder is dropped on the surface and then water is poured out. So the impurities is lighter weight particle. So the slope is the impurities is lighter in weight and then water is poured out. So this is the gravity separation method. Then the roasting and calcination process. So the calcination process, it is which the ore is heated to a high temperature below the melting point. So the melting point of metal in absence of air or limited the supply of air. So the concentration ore is strongly heated. Okay, the iron is strongly heated in the limited supply of air. Okay, in the reverberatory furnace. As a result, the moisture is driven out and sulfide, arsenic and phosphorus impurities are oxidized. So the process, the ore is heated in high temperature. And then below the melting point of the metal in the absence of air. Okay, in the limited the supply of air. This is the roasting and calcination process. So the next one is the smelting process. So the smelting process. So in the smelting process, smelting involves heating up ore until the metal becomes the chemical compounds. becomes the chemical compounds in the ore begin to break down. So in the smelting, the charge consists of roasted ore, the coke and limestone. The coke means carbon and limestone. Limestone in the ratio is 8 is 4 is to 1. Okay. So ore, coke and limestone 3. So 3 ratio is 8 is to 4 is to 1. So it is smelted in the blast furnace by introducing is through to the cup and cone. Okay, arranges the top. So in this region, the iron is heated in very high temperature. So collected the pure iron in the iron outlet. So this is the blast furnace method. So next one, the lower region is the compaction of zone method. So the temperature is 1500 degrees Celsius. Is the coke burns with oxygen. So the coke means carbon is reactive within the presence of air, oxygen, to form carbon dioxide. So in the the presence of carbon and oxygen is high temperature. The temperature is at 1500 degrees Celsius. So the carbon is burns. The coke is burns. The given product is carbon dioxide CO2. So coke carbon is C, oxygen O2, then carbon dioxide CO2. So heat is evolved. So it is the exothermic reaction. Since the heat is liberated. Then the middle region, fusion zone reaction. So first reaction, carbon react with oxygen to form carbon dioxide. So continuously the reaction, carbon dioxide is react with carbon. Okay, carbon dioxide is react with carbon in the presence of temperature 1000 degrees Celsius. So to form carbon monoxide, CO. Okay, carbon monoxide, CO. So first one is carbon C, oxygen O2, carbon dioxide CO2, carbon monoxide CO. Okay, then the next reaction, limestone, calcium carbonate is the limestone. So the limestone decomposed to calcium oxide. So limestone, calcium carbonate is CaCO3. In the presence of heating, carbon dioxide is formed. Then the next reaction, calcium oxide, is the slag reaction. Slag reaction. So the calcium oxide is react with the silicon dioxide to form calcium silicon trioxide, calcium silicate. Okay, calcium silicon trioxide, that name is calcium silicate. Okay, calcium silicate. So in the lower region reaction and middle region reaction. So the next one is the upper region reaction. So the upper region reaction is iron oxide, Fe2O3. So the name is hematite. Okay, hematite. So in the hematite is react with carbon monoxide in the presence of temperature is 400 degrees Celsius to form pure metal of iron, and carbon dioxide is liberated. Okay, this is the upper region reaction. Okay, so in the first one, lower region reaction, only react with in the presence of carbon and oxygen to form carbon dioxide. Then the middle region reaction, carbon dioxide is react with the carbon to form carbon monoxide. Then limestone. So the limestone, calcium carbonate is heated, is decomposed, okay, high heating, so the calcium carbonate is decomposed, okay, decomposed, so the product is carbon dioxide. Then another reaction, carbon calcium oxide and silicon dioxide, okay, calcium oxide and silicon dioxide is treated with to form the product is calcium silicon trioxide, that name is calcium silicate, calcium silicate. Then the upper Regier reaction, hematite Fe2O3, Fe2O3 is the ferric oxide is reacted with carbon monoxide to form pure metal of iron, so the molten iron is collected, at the bottom of furnace, removing the slag, so the ion is formed is called big ion, so the ion this formed is called the big ion, so the ion is called cast ions. So the physical properties of ion. So the next one, the physical properties of ion. So first point is the luster of metal and white in color, okay, white or green color. Then the high density and high malleability and high ductility. Then it can be the magnetized, it can be magnetic properties of magnetized. Then the next one, chemical properties. The chemical properties of ion, the first reaction is reaction with air or oxygen. So ion is react with oxygen, so ion symbol is Fe, ion symbol is Fe, oxygen symbol is O2, okay, oxygen symbol is O2. So ion is react with oxygen to form is ion tetroxide, okay, magnetic oxide, okay, ion magnetic oxide, okay. So Fe3O4 is black in color, okay, is black in color. So first reaction with the air and oxygen, ion is react with oxygen to form the magnetic oxide, black in color. Then the reaction with the moist air, reaction of moist air. So in this reaction, ion is react with oxygen in H2O, the air in the presence of some moisturized, so H2O in the presence of air. So ion moist air, H2O and O2 is react with hematite reaction. So hematite reaction, Fe2O3 is added H2O, is the rust is forming, okay, is the rust is forming. So in the moisturized air react with ion, it forms a layer of brown hydrated ferric oxide, okay, brown hydrated ferric oxide on its surface. So it is called rust. Rust is forming, is the corrosion, okay, is the corrosion of ion. So the rust is forming. So the ion is react with oxygen and moisturized H2O air. So in the rust is forming. So the rust is, the formula is Fe2O3 into X means the types of numbers, 14 or 16, anything. So the X H2O. Then reaction with the steam, so steam is passed over the red hot ion. So the ion is heated red hot in the presence of water, so it form Fe3O4 is magnetic oxide, okay, magnetic oxide. So ion is treated with water, then high steaming, so the magnetic oxide is formed. Then the reaction with chlorine, ion is react with chlorine to form ferric chloride. Ion symbol is Fe, chlorine symbol is Cl2, then ferric chloride, the symbol is FeCl3, ferric chloride. Okay, so ferric chloride, Fe2Cl6. So 3 is common, and Cl2, 3 into 2 is 6, so 6 chlorine. So the ferric chloride. Then reaction with acid. So the acid is hydrochloric acid, HCl, sulfuric acid, H2SO4, then nitric acid, HNO3. So ion is react with hydrochloric acid to form ion chloride. Then ion is react with sulfuric acid to form ion sulfide. Ion sulfide. So the first reaction, ion is react with sulfuric acid to give the product is ion chloride. Then hydrogen is liberated, hydrogen gas is liberated. Then ion is react with sulfuric acid to give the given product is ion sulfide. In the same, the hydrogen gas is liberated. Then the dilute nitric acid. So ion is react with nitric acid to form ion nitrate, ion dinitrate, and ammonium nitrate. Ion nitrate is FeNO3. Ion nitrate FeNO3 is ferrous nitrate. Ion in the chemical name is ferrous nitrate. So FeNO3 and the chemical name is ferrous nitrate, and ammonium nitrate, ferrous nitrate and ammonium nitrate, and then removal of water molecule. Then concentrator. So the first reaction is dilute hydrochloric and dilute sulfuric acid reaction. Then the second reaction is concentrated sulfuric acid reaction. So concentration sulfuric acid reaction in the product is ferric sulfate. So Fe ion concentrated sulfuric acid give the product is ferric sulfate, Fe2SO4 3, ferric sulfate. So the liberated of sulfur dioxide gas. Then removal of water molecule. Removal of water molecule. So today we are learn about extractive metallurgy of copper and extractive metallurgy of iron. So now your homework is all of you study about extractive metallurgy of copper. Extractive metallurgy of copper reactions and their uses. So all of you study and write in your classwork notes. Thank you, children.